Okay, we're finishing off Earth's atmosphere. We have a sense of how it got to be this way. There's some processes involved. We also have a sense of what's coming in to Earth. We've got the solar wind, we've got ultraviolet light, visible light, infrared light. Let's find out how each of these is blocked or where it's blocked and what's going on as that comes in through our atmosphere. So we're talking about our current atmosphere, our current 4 layers of atmosphere. Again, not getting too much detail, so if you take more courses you might get more subtlety in there, but this works pretty well. I'm going to sketch it over here, and it's pretty hard to sketch it to the right size, the right height. If you wanted to sketch the right height, this would be it about. I mean, you'd have a certain amount here, say 1, maybe 10 miles, 7 miles, say, and then twice as much here, and then that same amount here, and then a whole bunch up here. It's gas, remember, so there's not really a line. It just gradually fades into other things, and other things happen. But we'll get a sense of these 4 layers of Earth's current atmosphere. So let's do this. Let's sketch this out. Make sure you've got your chart here to fill in. And we've got the ground. And we'll go up a certain distance for these 4 layers. Now you might ask yourself, how high does the atmosphere go? So you could pause and take a guess. If you take a guess, it's easier to learn because then you go, oh, now I know. So let's put some answers. This first layer goes up, about 7 miles. You could think 10, fine with me, but about 7 miles. So like 10. Another 20 miles from here would be, something like 30. Again, you might see slightly different numbers in different books and different sources. As far as I'm concerned, just having a sense is what we're going for. Another 20, so 50 from the ground, 50 miles up. 50 miles up, just think about what you could drive to going in each direction. That's about an hour's drive, not quite, right? So just point your car up there to get there an hour or less. And then a big, thick layer, which actually goes up, and again, you'll see different names for this and different heights, but I'm going to give 200 miles above the ground where it really starts thinning out, and we don't have much left over. Okay, so we got these 4 layers. Great. Now, what's coming in? Well, we've got solar wind, we've got space debris coming in, we've got ultraviolet light, we've got visible light, we've got infrared light. We're going to see how they interact with our atmosphere. Great. Let's first name these things. So naming things is great. It's a great way to remember things. And if you know these names, and when people talk, you know exactly what they're talking about. So let's do the names. Okay. Now, we're going to start using lots of memory aids. We started with a Roy G. Biv, right? So, I-M-S-T, how do I remember that? Now you could come up with your own, T-S-M-I. If you use it, you have to know which way it goes, right? So a common memory aid here is, I must study this. Now memory aids are no good unless you know what that stands for. So we'll fill that in a second. I must study this. Or I like you're a student, so this must apply. I am so tired. Or one of my students just came up with, I'm a supreme taco. So whatever you got. I've got another one, if you'd like. So one of my sort of hobbies that I try to find time for is guitars. And it's a Stratocaster. You could look it up, find a picture. It's an electric guitar. So Stratocasters. So I stands for Iona. It's an ionosphere. But ionosphere really, but Iona. Mesosphere. Strato. So I own a mess of Stratocasters, but I don't even own one, so I'm tripping. And that stands for Tropo. So there's another memory aid. Whatever it is, know these. So I own a mess of Stratocasters tripping. I am so tired. I must study this. Those are the layers, the names of the layers. Let's see what goes on in each of them. All right, let's check it out. So, we got the solar wind coming in here. Remember that they got kind of funneled and focused into the, often into the polar regions, right? So, sun can flare up and send out more or less of these particles, solar wind particles. And they're coming in through here and they're high energy, and you better watch out because they're just going to really mess up all life on the surface of Earth. But luckily, as they enter the ionosphere, they tend to interact there, make that glow, and what we get here is nice pretty colors of the aurora. Okay. So in the ionosphere, what you need to know, and I've just got one thing for each until we get to the troposphere, is that the solar wind tends to glow, you know what, 50 miles up, that's where those lights are, that's where those glowing lights are, they're kind of interacting up there. And we got space debris coming through. We could have chunks, you know, golf ball sized chunks. We could have little sand green sized chunks, little bits. But space debris comes through our atmosphere. And of course, it can come all the way down, but oftentimes it creates streaks. Remember those streakers from chapter 1. So where do those streakers go? Well, those streakers come on through, and they tend to make it through here. Little chunks going through here. And you might guess, the way I've done this, is that they're going to streakers. And as they make those streaks, we call them meteors. Now that's pretty darn nice, right? Meteors in the mesosphere, right? And again, they can come down farther in the atmosphere, but you know, as I said, those streaks, so those aren't stars, right? If a star was up 30, 40 miles up above us, we'd have a trouble. These aren't called shooting stars, but they aren't, and we'll talk more about that in chapter 9. So we've got these bits coming through, making the gas glow in the ionosphere, and creating streaks in our sky up there in the mesosphere. And now we got the UV coming in. Now UV is dangerous stuff, right? UV is very dangerous stuff. In fact, if you think about it, you go to a hospital, they want things sterile. They want sterilized things. You don't want viruses. You don't want bacteria. You don't want things that are going to cause problems, right? And if you're already weak. So they sterilize things in the hospital. And how do they do that? You can sterilize things by exposing them to ultraviolet light. Remember, it's that high energy light. So ultraviolet light, we don't really want to sterilize Earth. Not good. So we're fortunate to have this. High energy light, wiggle, 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 coming on through, and as you might guess, boom. There's something in the stratosphere. UV is absorbed by ozone, and ozone, by the way, is 3 oxygens. Where does it happen? In the stratosphere. Right? Now, some gets through, but a lot of the UV, which is very damaging, gets absorbed in the ozone, O3. Okay? All right, great. So that's a good thing because it's a sterilizing thing. Now, just a little bit more about ultraviolet light. As this comes in and gets absorbed, we get protection. Again, there's UVA and UVB. That has to do with how close it is or far away from violet. You can look that up. It's pretty easy. But you know, ultraviolet, you can get a pen, and it just takes a couple of batteries, and it creates ultraviolet light. So you can create that ultraviolet light. Black lights, they use ultraviolet. You can look into that, and you can take that and you can put it into water. So what I have is a black light pen that I use for traveling or backpacking or camping. Put it in some water, about a minute and a half, slosh it around. That ultraviolet light has hit the DNA of that stuff and broken it down so it can't reproduce, and it can't reproduce in my gut and cause problems with giardia and things like that. So again, just remind yourself, ultraviolet light is high energy light. We don't want it hitting the ground. It comes in and gets absorbed here. And we're good. So we got aurora, we got meteors, we got meteor showers, things like that. We got the ozone absorbing the ultraviolet light. Great. We're doing okay. So now we've got visible light. So what happens to the visible light? Oh, I knew I was missing something. That is important point here. We need ozone up there, right? We want to block the UV. So if you've heard about holes in the ozone, that's a problem. If you let UV in, that's a problem. So in the 70s, the holes in the ozone became a significant issue, and people looked into this and said, what are we doing? Is it our fault? In fact, it was humans' fault. Humans had a huge impact on the ozone. We'd make things like styrofoams and hairsprays and aerosols and things like that with something called a CFC. And it was found that the CFC would rise up, interact with the ozone and break it down, letting ultraviolet in, dangerous situation. So realizing this, chemical engineers said, hey, we can make some of the stuff. There's some that we should probably stop making if we can. And we can make that stuff with something called an HFC. So an HFC doesn't do that, doesn't break that ozone down. And so the ozone replenishes itself with sunlight. That's a good thing. And so it's replenished. Now there are still some issues around the southern hemisphere. You can look at this ozone holes and things like that, so things that happen. But we have figured out that we were a problem, and we've managed through chemical engineering and so on to try to solve that problem somewhat. Okay? So that's our interaction with that environment. Now let's look at visible light. Visible light, what does it do? So now I know, oops, UV blocked by what and where? You fill that in, make sure you do that. Instead of just copying the letters, but really think about it. Now I've got Reggie Bev, backwards. So what happens? Wait a minute, you look up at the sun, you see the light, right? You go out there and you can wear different color shirts and you can see that all these colors are coming through. So this comes on through. And the blue comes on through. But the blue hits our atmosphere and scatters, right? Giving us our blue skies. But it comes on through. It bounces around and gets in here. And the green comes on through, and there's a little bit of scattering there too. Green comes on through, and the orange and the yellow come on through. And the red comes on through. Okay, so the visible light comes in and it warms the surface. We studied seasons. We talked about tilting towards the light and away from the light. And so the visible light comes through, and maybe that's why our eyes are not tuned to radio, but they're tuned to visible light, right? So adaptation. So visible light comes through the atmosphere and warms the surface. And so if you put a telescope here, you can see all the visible light coming through. If you put one here, you're going to have a hard time seeing UV, aren't you? We'll talk about that later. All right, so let's put that in here. Visible light warms the surface. Okay, that's going to be an important part of the greenhouse effect. We'll get to that in a moment. One more thing we need to do is the infrared. What happens to the infrared? Well, as I said, it's blocked from the outside and trapped from the inside. What does that mean? Infrared's coming on through. It's coming on through, and something happens here. So let's talk about this layer. We've got aurora, meteor, ozone here. And we haven't talked too much about the troposphere. The troposphere. What's going on with the troposphere? What is it? All right. Well, this is where we have clouds and weather this is where we have mostly nitrogen and oxygen. 80% nitrogen, 20% oxygen around there, right? And maybe we should say 80%, 20%. And this is where we have something called GHG. GHG, what does that stand for? Greenhouse gases. So right in here, we have something called GHG, greenhouse gases. Okay? And what are those? Well, greenhouse gases, for example, would be water, which is 2 hydrogen and 1 oxygen, vapor. We've got carbon dioxide. We've got methane. And other bits of stuff as greenhouse gases. What do they do? Well, what they do is they block the infrared. They absorb the infrared and re-radiate. So effectively, the infrared from the outside will bounce off, not get through. So a lot of the infrared that's coming through or coming in doesn't make it through. Why? Because of the greenhouse gases. All right. So if you're trying to look out into space at these low energy glowing things, you're not going to be able to see them, are you? Unless you get up higher in the mountain or get outside of the atmosphere. Okay, so it doesn't get through. So, that's interesting. Well, I said that's blocked from outside by greenhouse gases in troposphere. But wait a minute. Where's the greenhouse effect? Visible light warms the surface. A warm surface glows or radiates or creates, however you want to think it, infrared. All of us are. We can't see it, but we're glowing infrared. And so it's not the infrared that's coming in, it's the infrared created by the warm surface, and that infrared goes up. And some of that, so that's IR now, and some of that gets out. So some of that warmth effectively gets out. And some IR is trapped inside from what you can think of as a blanket, an IR blanket, keeping the IR in. So we can think of it as a greenhouse gas blanket. And that's really important for certain worlds. We see different worlds. It's a greenhouse gas blanket. Why? Visible light comes in, warms the surface. A warm surface makes infrared, but infrared can't entirely, at least, get out through the greenhouse gas. Now, if you go to sleep and you have too thick of a blanket, it's going to be too warm. So if that blanket gets thicker and thicker, and the blanket of water vapor, carbon dioxide, methane gets thicker and thicker, your world is going to warm. If that blanket gets thinner and thinner, your world is going to cool. Maybe we should get rid of all the greenhouse gases, vacuum them up. And what would we end up with? A ball of ice, frozen oceans. We need a little warmth. We need greenhouse gases. We certainly need water and water vapor, right? We need carbon dioxide. Methane? I don't know. Maybe there are worlds where creatures thrive on methane. There's methane cycles. Who knows, right? We'll talk later about that. But we need this blanket, and it changes. It's always changing. See, Earth has gone through ice ages, right? And what happened to all the ice? Well, it melted. So it's gone through global warming. and global cooling and global warming. The Little Ice Age, you can research that, the Little Ice Age, not too long ago. What caused that? Do we really know? There's lots of factors. So we do know a lot more. We can take a lot more measurements. There's definitely been advances, but it's a very, very complex system. So we have greenhouse effect here, a greenhouse gas blanket. If there's too much, the planet becomes very warm. If it's too little, it becomes cooler. Just right is nice. However, it changes. Earth has naturally changed. The question is, how much are we affecting this? We know we are, we know we're contributing, but how much? And then how does Earth adjust to that? So those are very difficult questions. Most people think, yes, the Earth is warming, but you got the sun affecting it. So you got flare-ups and sun cycles and things like that. You got other variations. So it's a tricky business to figure out, right? So imagine this, part of that cycle, remember in the last video, how carbon dioxide gets broken down to carbon, releasing oxygen by what? Well, plants do that. So now you get warmer, nice tropical environment, and you might get more vegetation going farther north and farther south. And more vegetation is going to pull out the greenhouse gas of CO2 and give back oxygen. All right, so then it's gotten warmer, more plants make it for a thinner blanket, and the temperature comes back down. These tend to die off, they don't like it that cold. Right? That's getting cool, not many plants, CO2 builds back up. Wait, it's getting warmer, more plants. There's one cycle, another cycle. Much more complicated, you can look at it if you like. Very complicated cycle really, but the water. If you warm water, well, does it absorb more? If you have water that is absorbing more CO2, fine. So maybe a warm water would absorb CO2 more. And now I got less CO2, so I got a thin blanket. So now it's getting cold. Now I don't absorb as much CO2. The CO2 builds up. Now it's getting warmer. Then you absorb the CO2. Then it gets cooler. You don't absorb CO2. It builds up. Okay. So warming, cooling. Complex, interesting cycle for geologists, geographers, chemists, physicists, biologists, certainly involved in this very complex cycle. And so what can we do? We can consume less, right? Perhaps we should eat a little bit less beef with the methane and the cattle affecting our rainforests and things like that. Perhaps we should have fewer kids, but I will get to say on this video my little policy is to educate, not legislate. Educate as much as we can. We of course need some regulations and some legislating, but exactly how you live your life, we can make our personal choices to contribute positively and still enjoy our lives. So this is our greenhouse gas and our greenhouse effect, and we will see it on other worlds in dramatic fashion. I think we've got it. Just go back through and summarize.